All right, so we're going to take a look at looking back from thinking with mathematical models, and we're going to be examining what we've learned about linear and inverse variations. And we're going to start by going to the farm. That's right, we're going on a field trip to see Miss Yemma at her farm and her pigs and her goats. And did you know she's putting in a little train ride too? Oh yeah, it's going to be great. So here we go. The average growth of a properly fed pig. Oh my goodness, that is a big animal. They start out so cute. Okay, so we see that the age is, as the pig gets older in months, the weight gets a lot bigger really quickly. Can you imagine growing almost 270 pounds in 6 months? Oh my goodness, that's huge. All right, so question A is asking us, maybe, or maybe not. Question A is asking us, make a graph of the age and weight data and then draw a line of best fit. And then obviously the next part is we're going to find the equation in y equals mx plus b form. Slope-intercept form. All right, so here we go. Properly fed pig. So the first thing I'm going to do is I need to assign variables on the axes. And I know whatever variable is listed first in the table is going to be the independent variable. So therefore it goes on the x-axis. So we're going to say that age has to go down here. And this really does need to be the first thing that you do. So age, and we're talking about months. Which means that weight must go on the y-axis, and this is in pounds. So now that we've gotten our variables listed on the axes, we are going to have to scale this graph. We need to put the numbers on the both axes. And we're going to go with, come on. So obviously age, we go from 0 to 6 months, so we need to get 0 to 6 months on our graph. So I'm going to start at 0, which makes obvious sense. And I have 15, I think I have 15 numbers. So really, the only thing I can do is I can count by, twos. If I have 20, I can count by 3. So let's see. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. I do have 18 lines, and I want to have, wow, that plane is close to us. We want to have the largest graph possible. So I'm going to go ahead and count 3 lines. There's 1 month, 2 months, 3 months, 4 months, 5 months, 6 months. All right. Now the y-intercept is a little trickier. We need to go from 0 pounds all the way up to about 300 pounds. So if I have 20 lines, how many times does 20 go into 300? Well, 20 goes into 300 15 times. Oh, okay. So I can actually count by 20s and probably be okay. So we're going to start with 0, 0 at the origin. So 20, 40, 60, 80, 100, 120, 140, 60, 80, 200, 220, 240, 260, 280, 300, and we can actually get up to 400 here. And that's probably going to be just fine for our graph. So now it's time to graph the points. So our first point is going to have to go at 0, 3. So 0, 3, well, that's going to be barely recognizable on a scale of that's going all the way up to 400. So that's just a slight bit above the origin. So there's our first point. Our next point, 1, 48. So that's 1 over 2 and just a little bit more. Then we have 2 and 92. So 2 and 92 is just going to be under the 100, just barely. 3 comma 137. That's almost at 140. So here's 100, 140. So then we have 4 and 182. So go over to 4 up to 182. So that's almost 180. Just a little bit above. My goodness, I am starting to see a pattern here. Are you? So then we have 5 comma 228. So it's just a little bit over that one. There we go. All right, and 6 comma 700 or 273. So that's just under 280 right there. All right, so we have the spots or the dots located, and now we're making a line of best fit. Now I can see the data isn't exactly linear. Like if I look at the 2 months, it looks like he grew a little bit less than he grew for the rest of the time. Well, that's only because I located that dot in the wrong place. Oh my goodness, shame on you. You should have told me about that. So 2 comma 48, or 92 rather. Let's put it right here. Okay. Now it looks almost exactly linear. All right. So I'm going to take my ruler, and you should take a ruler too. And I'm going to say that it makes sense to have a Y-intercept of 3 because mammals typically are not born with no weight. They typically have some weight to them. And we can go ahead and draw a line of best fit that goes right down the middle of most of the data. So that's a pretty good line of best fit. I mean, we have some dots that are just a bit over the line of best fit, some dots just below the line of best fit. One dot looks almost exactly on it. So we have a good line of best fit. And it's important to remember that when you are doing some experiment, you're never ever going to get perfect data. So if the data is super close to linear, this is a linear relationship, which allows us to draw a line of best fit. So when I'm trying to get the slope, I think it might be a little more informative to look at the table for the slope. So what's the difference between these two? Well, that's 45. No, I really do want to use this. What's the difference here? It's 40. It's definitely 40. And that's 44. The difference here, that's a little bit bigger, I think, so that's 45 again. What's the difference here? 45. All right, so right now I'm willing to go ahead and say that this has a slope of approximately 45. If you have a slope of 44, that's fine, I get it. So we're going to say that the weight, W, the weight is equal to 45 times however months old this pig is, plus 3, because they're about 3 pounds when they're born. Now, obviously, this line of this relationship is not going to last forever because the pig doesn't grow forever. But for the first 6 months, this looks like a linear growth model. So we're going to scroll down a little bit, see what other questions we get to answer. All right, what do the values of M and B in your equation tell you about the pig's growth? Well, the 45 represents how many pounds you can expect a pig to put on every month. B is its birth weight. And use your equation to estimate the pig's weight in 3.5 and 7 months. All right, because maybe it has a vet appointment at 3.5 months. All right, so we are going to go ahead and use this equation. So we have W, that's what we're trying to find, times 45 times the number of months, 3.5 plus 3. So I'm going to pull up my calculator. I'm going to go 45 times 3. I'm going to get 135 plus the 3 pounds at birth. And so I'd expect the pig to weigh 138 pounds at 3.5 months. Well, what about 7 months? Same idea. Weight is equal to 45 times 7 plus 3. 45 times 7 plus 3. So I would expect the pig to weigh roughly 318 pounds after 7 months. All right, so that's question 1.